Let's take a walk through the Bluetooth demo LabVIEW project. I have the Digilent PMOD BT2 already wired up to MXP connector B. I have the demo VI running in the lower left, and the inset in the upper left shows the behavior of the RN42 module. I'll begin by placing the module into reset. At this point, I'm going to select Add a Device. The module is discoverable as soon as I take it out of reset. And you'll see the green status LED blinking at a medium pace, telling you that it is discoverable and the configuration time window is in progress. Now, Other seems like kind of a generic name. Let's try this again. The module is already discoverable when I select Add a Device. At this point, Windows is able to recognize the name that is being broadcast by the Bluetooth module. I'm going to go ahead and double click that. I need to enter the device's pairing code. This default value of 1234 is something that can be changed if you prefer a different value. Now, this driver installation process might take a little bit longer or a little bit quicker. It just kind of varies. But we see that it's trying to spend a little time doing the driver installation. I notice that COM7 is appearing. Let it think for just a little bit longer. Now you see that the green LED is blinking at a slow pace, telling us that the 60-second configuration time window has expired. So we'll come back to that in a little bit. Now I want to look at the Bluetooth devices. And here's the RN42. Go ahead and double click that. We have 4 tabs of interest. In particular, hardware tells us that we have COM7 as the associated COM port, and we're using Serial Port Profile, or SPP, which is associated with COM7. The last 4 digits of the unique identifier are associated with the default name for the RN42 Bluetooth device. Now I'd like to send and receive characters from my Bluetooth capable laptop and have those processed by the Bluetooth demo on my Rio. I'll be using the PuTTY terminal emulator. Go with the serial connection type. Need to change the baud rate and the serial line. Serial line on my laptop computer that's associated with the RN42 is COM7. The baud rate is 115.2 kilobaud. Under serial, we see that the baud rate has already been adjusted. We need 8 data bits, 1 stop bit, no parity, and no flow control. Be a good idea to save your configuration away. You can give a name for the saved session, and then you can simply load that later. In fact, when you have a saved session, you can simply double-click on the name, and it immediately opens up a terminal emulation window. Note that when the connection is established, the green status LED goes off. At this point, I don't see much, except I do observe that the status light is active. I'm going to try typing ABC and see what happens. So there's A. Let's try B and C. All right, we see these being picked up by the RN42 and then passed to the MyRio. I'm going to enable echo, and now each time the MyRio receives a character, it immediately transmits that back, and we see those appearing in the PuTTY window. I'd also like to draw your attention to the fact that the low 4 bits of each character are displayed on the MyRio onboard LEDs. Now, when you type D, that gets special treatment. D causes the program to send back the MyRio date, and similarly T sends back the MyRio system time. Let's try the flow control signal CTS. I'm going to type some characters, but I don't see any activity right here. Now, as soon as I release CTS, we see in very quick succession those buffered characters are received. All right, let's try something a little different. I'm going to try to enter the RN42 command mode by typing $3 in a row. I don't see anything happening, and that's because we need to restart the 60-second configuration time window. Click the reset button, which is the same as power cycling the RN42. This restarts the 60-second configuration time window, and you see a medium blink rate on the green LED on the RN42 module. I'm going to restart my putty session. And let's give this a try. $3. I didn't have local echo turned on, so you couldn't see them, but we now see the command prompt. Notice that the green LED is blinking in high speed mode, and that tells us that we are working on configuring the RN42. H displays help, shows you all the possible commands. You'll see there's many different set commands. You can manipulate all sorts of properties of the RN42. For example, here's where you could change that pairing code 1234. You could change that to something else. Draw your attention to some of the commands for displaying information such as basic and extended settings. D and E in particular. You can also look at the firmware version with V. Let me try typing a D to see the basic settings. Particularly, we see the RN42 name, see the baud rate, see the current pin code or pairing code. E gets you the extended settings, and that tells us that the service we are using right now is serial port profile. Type V to display the version, and we're using firmware version 4.77. Finally, type 3 hyphens in a row to exit command mode. Before leaving putty, I wanted to mention that you do a control right click to see all of the available options in the terminal window. All right, let's start getting into the details of the block diagram. We have an initial configuration at the beginning, main loop right here, waiting for characters to become available, reading those characters, echoing back if necessary, and then doing some processing. I have a second parallel loop for managing the reset and CTS output pins, and then monitoring the status and RTS pins. And over here on the far right are some cleanup activities when the VI shuts down. All right, let's get into the configuration area. Look under My Rio, Advanced I/O, UART, and this gives you all of the low-level routines for working with the UART. Let's get started with the configure serial port. You can specify the desired UART on either connector A or connector B. Need to specify the correct baud rate, 115.2 kilobaud. Number of data bits is 8. Go with the default timeout, but then I'm specifically disabling the use of the termination character. Now this task is fed into the main loop, waiting for characters to become available, and that's what you get when you select bytes at port. This reports an integer that tells you how many bytes are available. So the outer case structure says that if we have pending bytes to read, then go ahead and process those inside this panel. If there are no bytes available, simply do a pass-through of the error cluster. Now, when characters are available, I read one character, display it as incoming character on the front panel, and then also pass that character through this case structure. When the case structure is false, nothing special happens. When it's true, I'm using Visa write to write that character back out to the UART. So in this way, we have an echo feature, and character echoing is enabled with this Boolean switch right here. Now, depending on the value of the incoming character, I take one of three possible actions, and that's this inside case structure. You have the default panel, the T panel. This is where the system time is written back out to the UART, and the D panel is returning the system date. These VIs are located under the timing subpalette. In particular, you have get, date, and time in seconds. It's located right here. Then get, date, time string accepts that result and then formats it in a string either for time or for the date. Here I'm concatenating a carriage return line feed combination onto that string. Concatenate is located right here. The final string then is sent to the Visa write, and that gets returned back to the UART. For all other characters, the default activity is to show the lower 4 bits on the onboard LEDs. Basic idea is to convert that character into both its ASCII hex code, you can see that here. Looking under display properties, I'm displaying this as a hexadecimal value using a minimum field width of 2, 0 padded, and then I'm also showing the radix just to make sure that's clear. That's the little X in front of the 20. The incoming character is using the / codes display. You could also use hex display if you like. Now here I'm using unflatten from string. This is extracting the numerical equivalent from that character. From string is located right here. This is then fed into number to Boolean array, which is located under the numeric palette. And this Boolean array is fed to index array. And this is where the lower 4 bits are picked out and then fed to the onboard LED, located under myRIO, onboard, and LED. All right, that's about it for the main processing loop. Let's go to the secondary parallel loop. Here I'm controlling both the reset and CTS pins and then monitoring the status and RTS pins. Look under myRIO to see the digital in and digital out express VIs. You can configure these by double-clicking on the panel, and you can specify the appropriate DIOs for the digital output and input as well. Now let's follow the error cluster as it works its way through the primary loop. That controls the order of events. I OR that with the stop button on the front panel. And either stopping or an error condition breaks out of the loop and then sets the value true for this local variable. Local variables are located right here, and you can associate a local variable with any front panel control. So in particular, this would be with the stop button. Now, this local variable can be read by the secondary parallel loop. For example, pressing the stop button here ultimately means that the local variable conveys that fact to the secondary loop. Now here you needed to change that to read mode. That's where you can switch back and forth between write mode and read mode. Now when this goes true, that tells you that the loop has stopped. You can break out of the secondary parallel loop. Error conditions also can break you out of this loop. So either one of those is going to set the local variable true. In effect, the secondary loop pushes the stop button for the primary loop and breaks that one out as well. Here I'm merging the error clusters together, passing through a flat sequence structure where I release the stop button by using a false on the local variable, pass through the simple error handler, and then execute a myRIO reset to finish up. Should also notice that I'm using 100 milliseconds to pace each one of these loops.